Space is vast and mysterious. It calls to us, inviting exploration. But getting there isn't easy. For years, NASA relied on the space shuttle to reach the International Space Station. When the shuttle retired in 2011, America lost its way to space. We had to hitch rides with Russia. This was expensive and risky. NASA needed a new plan. Enter the Commercial Crew Program. This idea let private companies build spaceships for NASA. Two companies rose to the challenge: Boeing and SpaceX. They would compete to ferry astronauts to the ISS. This competition would drive innovation and lower costs. America needed its own ride to space again. Let's look at the two spaceships making this possible: Boeing Starliner and SpaceX's Crew Dragon. Boeing's entry in the space race is the CST-100 Starliner. CST stands for Crew Space Transportation. Starliner looks like a big white gumdrop. It's designed to carry up to 7 astronauts, but usually carries 4. Inside, Starliner is roomy and high-tech. It has touch screens and comfy seats. The capsule can fly itself, but astronauts can take control if needed. Starliner is built to be tough. It can withstand the harsh conditions of space and the fiery return to Earth. Boeing designed it to be reused up to 10 times. Starliner launches on top of an Atlas V rocket. Once in space, Starliner uses its own engines to reach the ISS. Boeing has faced some challenges but is working hard to make it safe and reliable. SpaceX's Crew Dragon is a sleek, modern spaceship. It looks like something out of a sci-fi movie. Crew Dragon can carry up to 7 astronauts but usually carries 4. SpaceX designed it to be simple and safe. Inside Crew Dragon, everything is controlled by touchscreens. The seats are custom-made for each astronaut. Crew Dragon can fly itself to the ISS. Crew Dragon launches on top of SpaceX's own Falcon 9 rocket. This powerful rocket can land its first stage back on Earth. SpaceX has already used Crew Dragon to send astronauts to the ISS several times. It's proven to be reliable and efficient. Launching a spacecraft is a complex dance of technology and timing. It all starts days before liftoff. Teams of engineers and technicians prepare the spacecraft and rocket. They run countless checks to make sure everything is perfect. The astronauts go through their own preparations. They practice procedures and get fitted for their spacesuits. As launch day approaches, excitement builds. The rocket is rolled out to the launch pad, fuel is loaded into its tanks. The astronauts arrive at the launch pad a few hours before liftoff. They take an elevator up to the spacecraft and climb aboard. Once inside, they run through more checklists. The final countdown begins. Mission Control watches every system closely. As the clock ticks down, the rocket's engines roar to life. The ground shakes. Flames and smoke billow out. Then, with incredible force, the rocket lifts off. The first few minutes of flight are intense. Finally, the spacecraft separates from the rocket and is now in space, ready to begin its journey to the ISS. Once in orbit, the real space journey begins. The spacecraft isn't at the same height as the ISS yet. It needs to catch up to the station, which is zooming around Earth at 17,500 miles per hour. This takes careful planning and precise maneuvers. Both Starliner and Crew Dragon use their engines to adjust their orbits. The spacecraft slowly raises its orbit over several hours. It fires its engines in short bursts. Each burn moves it closer to the ISS. The astronauts and ground control work together during this phase. They constantly check the spacecraft's position and speed. As the spacecraft gets closer to the ISS, things get more delicate. The final approach is slow and careful. The spacecraft uses special sensors to line up with the docking port. The final moments of docking are automatic. The spacecraft gently connects with the ISS docking port, creating an airtight seal. Life on the ISS is busy and exciting. The station is a giant laboratory floating in space. Astronauts spend their days doing experiments and maintaining the station. Both Starliner and Crew Dragon are designed to support these long missions. They bring fresh supplies and new equipment to the ISS. The spacecraft stay docked to the station for months. During this time, they serve as lifeboats. If there's an emergency on the ISS, the crew can use the spacecraft to return to Earth quickly. While docked, the spacecraft aren't idle. Their systems keep running, managed by the ISS crew and ground control. Regular checks ensure they're ready for the return trip. The spacecraft also provide extra living space for the crew. Both Starliner and Crew Dragon can carry cargo as well as people. After months in space, it's time for the astronauts to come home. The return journey is just as complex as the trip up. It starts with careful preparations. The crew packs up experiments and personal items, they put on their spacesuits and strap into the spacecraft. Then, they close the hatch between the ISS and the spacecraft. Undocking is a slow, careful process. The spacecraft releases its grip on the ISS. Small thrusters push it gently away. Once it's a safe distance from the station, the spacecraft fires its engines. This slows it down and lowers its orbit. Now gravity takes over, pulling the spacecraft back to Earth. As the spacecraft enters the atmosphere, things heat up. A special heat shield protects the crew from the intense heat of re-entry. Starliner deploys parachutes and lands on solid ground while Crew Dragon splashes down in the ocean. Recovery teams are waiting to pick up the crew and the spacecraft. The astronauts are home, their mission complete. While Starliner and Crew Dragon have the same job, they're quite different. Let's look at some key ways they stand out from each other. First, there's the launch vehicle. Starliner rides on an Atlas V rocket, while Crew Dragon uses the Falcon 9. The Falcon 9's reusable first stage makes it unique in the space industry. The landing method is another big difference. Starliner touches down on land, using airbags to soften the landing. Crew Dragon splashes down in the ocean like the Apollo capsules of old. Inside, the spacecraft have different layouts. Starliner has a more traditional design with physical switches and controls. Crew Dragon is all about touchscreens, giving it a more futuristic feel. Boeing's design is more conservative, building on proven technologies. SpaceX has been more willing to try new things like reusable rockets. The Commercial Crew Program marks a new era in space exploration. For the first time, private companies are sending people to orbit. This opens up exciting possibilities for the future. It's not just about going to the ISS anymore. These spacecraft could be the first step towards space tourism and private space stations. NASA's goals go beyond low Earth orbit. They want to return to the Moon and eventually go to Mars. The lessons learned from Starliner and Crew Dragon will help with these ambitious plans. These spacecraft prove that public-private partnerships can achieve great things in space. The competition between Boeing and SpaceX drives innovation. Each company pushes the other to be better, safer, and more efficient. This benefits everyone. It means better technology, lower costs, and more opportunities for space exploration. As we look to the future, the possibilities seem endless. The journey to the stars continues.